Let's create the address mother class next. It's much the same as state mother, but the address class has a few more properties than state had. We'll just fill them in with random values as well. Remember, these values are only for the consumption of automated tests, and as long as I don't generate strings that are too long to pass validation, the values are totally arbitrary. Since an address requires a state, address mother will call state mother to provide that. Now let's update all of the existing tests that were creating addresses to use the new address mother instead. And the tests should all still pass. You can see that the intention of the tests is much clearer now. When a future developer looks at this code, they no longer need to wonder if there was anything special about the magic string values that were used in the previous version of the test. Clearly, this test just needs an address, and not some special case of address. Many questions the future developer would have had about the context have just evaporated. The context is clear and concise. But let's suppose you needed a specific address for some reason. You could either override the important properties directly in the test, which is heading back down the original road of each test knowing too much, or you could add more methods to the address mother class. I'll add a method to create a canned address with predetermined properties. Let's make a shipping address for Joe Customer. You can keep adding as many special cases as you need, and then choose the appropriate method when writing your tests. This is very similar to the idea of establishing test personas, representing users with well-known characteristics. Over time, these canned objects, like Joe Customer, become known and reused by many different tests, and can be referenced by name in conversations between developers and QA team members. Rather than watch me type out all of these object mother classes, let's jump ahead and I'll show you the final result. Now you can see that I have a full suite of object mothers. If I start at the top of the hierarchy with the order mother, you can see how it simply leverages the other object mothers to create their respective child objects as needed. It uses getRandom to decide on a random number of order items to include in the order, each of which will contain a random quantity of products created by the product mother. Compare this to the original test, where we used to have an impermeable wall of text that didn't reveal its meaning. We now have a concise context that clearly communicates what's going on. This test is simply operating on an order that we presume to be valid. I could always modify the properties of the object graph returned from the object mother, invalidating individual properties as needed to set up the desired scenario for an individual test, and it would be obvious to a reader that these modifications are somehow important to the test. Now let's add that country business requirement back in again. As you can see, the tests broke just as they did before. But this time, I only need to fix my code in one place. I'll call country mother from state mother. And just like that, all the tests that were broken by the addition of country are fixed all at once. It's best to create objects in one direction only, and I've chosen to go top-down, with parents creating their children, and not the other way around. You can see that starting at order, I know I'll eventually end up needing a country, but if I were to start at country, there's no way to know which state it should be attached to. And there's no way to know whether the address was meant to be the customer's billing address or his shipping address. Building the hierarchy from the top down solves this problem, as well as avoiding the infinite loop that would be caused by state mother calling country mother, which in turn calls state mother. This is still code, and we still have to avoid doing dangerous things with it. Before we go any further, let's go back to the state mother class. One thing I might want to do while I'm here is to make sure that the generated country includes this state in its collection, in case any of our production code tries to use that relationship. I'll just add a line here at the end of the factory methods that adds the newly created state to the states collection of the country which we created by calling the country mother. Another common pattern is to add an overload or optional parameter to the factory methods that take in the parent, so that country mother could call state mother, but pass in the country that the state should belong to, avoiding the infinite loop. But that's still creating the hierarchy from the bottom up, so I won't be pursuing that. And there we have it. The solution has been refactored to extract test object creation into a series of object mother classes. In this module, we looked at ways to remove concrete knowledge from our tests, identified the kinds of code to be factored out of our tests, added a random value generator to the project to eliminate magic values and the confusion that they cause. We used that random generator to create several object mother classes, and combined those object mother classes to generate a complete object hierarchy. Finally, we refactored the existing tests to use the object mothers rather than building everything themselves. In the next module, we'll continue to refine the object mother classes, turning them into what's known as object builders, a more modern and expressive implementation of the same basic idea.